Hi, this is Alex from devstories.eu. High Performance Python Async, Episode 1 of 17. What if you could double the performance of your Python async code without rewriting a single function? That is the exact promise of the technology we are looking at today, uvloop architecture. When developers talk about standard Python async, they tend to mix up two distinct layers. The first layer is the application programming interface. This includes the async and await keywords you type, the futures, and the tasks. The second layer is the event loop itself. The event loop is the internal scheduler that monitors sockets, manages network connections, and decides which task runs next. Standard Python provides both the interface and a default event loop written in pure Python. Here is the key insight. The interface and the event loop are decoupled. Python allows you to swap out the underlying scheduler without changing the syntax you write. Think of it like a car. The async API is the steering wheel, the pedals, and the dashboard. You interact with those directly. The event loop is the engine under the hood. Swapping the default Python event loop for uvloop is like dropping a V8 engine into your vehicle. You still steer and brake exactly the same way, but the car moves significantly faster. The core of uvloop relies on two architectural choices to achieve this speed. First, it is a drop-in replacement written entirely in Cython. Cython compiles Python-like code down to highly optimized C extensions. This eliminates the overhead of the standard Python interpreter when executing the hot paths of the scheduler. Pure Python event loops spent a lot of time creating internal objects and managing interpreter state just to handle routine network events. Cython strips that away. Every time the loop checks a socket or wakes up a task, it executes native C code instead of routing through pure Python. Second, uvloop delegates the actual operating system interactions to a C library called libu. If that name sounds familiar, it is because libu is the asynchronous I/O engine that powers Node.js. It's battle-tested, highly tuned for network-heavy workloads, and handles all the complex cross-platform details of asynchronous networking. By wrapping libu in a tight Cython shell, uvloop brings that exact same performance profile directly into Python. The architectural result is massive. By bypassing the pure Python scheduler and relying on a compiled C engine, uvloop makes your async I/O applications at least twice as fast. In many benchmark scenarios involving high connection concurrency, it allows Python to rival the performance of compiled languages like Go. You get the developer velocity of Python with the raw execution speed of native C networking. The transition requires zero changes to your business logic, your database queries, or your API endpoints. The fundamental takeaway here is that performance bottlenecks in standard Python async are rarely about the language syntax, but rather the execution engine, and replacing that engine gives you native C speeds while preserving your existing Python abstractions. If you want to help support the show, you can search for DevStories EU on Patreon. That's all for this one. Thanks for listening, and keep building.